Look at this table. The quantity of books placed on it can be expressed in terms of numbers by counting them. Similarly, the quantity of apples is expressed in mass. Have you ever thought how the basic unit of these matters is expressed? We know that the basic building blocks of all the matter that we see in the universe are atoms, and the atoms combine to form molecules. Atoms and molecules are extremely small in size, and their number in even a small amount of any substance is really very large. Is it possible to weigh and perceive these entities? Is it possible to count the number of atoms and molecules in a given mass of matter? How can we obtain a quantitative relationship between the mass and the number of these particles? Come, let us seek the answers of all such questions in the module Some Basic Concepts of Chemistry. After reviewing this digital content, the students will be able to appreciate the importance of chemistry in our day-to-day life, explain the characteristics of 3 states of matter, classify different substances into elements, compounds and mixtures, determine significant figures, convert physical quantities from one system of units to another, explain various laws of chemical combination, calculate atomic mass, average atomic mass, molecular mass and formula mass. Define the terms mole and molar mass, determine empirical formula and molecular formula for a compound from the given experimental data, solve the problem based on the stoichiometric calculations. Importance of chemistry. Chemistry is the branch of science that deals with the composition, structure and properties of matter. It is also called the science of atoms and molecules. Chemistry is concerned with the changes we see around us, like rusting of iron, growing of grass, burning of wood, and many more. It plays a critical role in man's attempt to feed the world population, to tap new sources of energy, to clothe and house humankind, to improve health and conquer diseases, and to monitor and protect our environment. Because of this responsiveness to human needs, chemistry has become a crucial factor in the nation's economic well-being. States of matter. Matter is the material part of the universe. Anything which has mass and occupies space is called matter. Everything around us, for example, book, pen, chair, table, computer, water, is composed of matter. The matter can be classified in 2 different ways. A. According to its physical state, and B. According to its chemical composition. On the basis of the physical state, matter is classified as solid, liquid and gas. In solids, the constituent particles are held very close to each other in an orderly fashion, and there is not much freedom of movement. Thus, solids have definite volume and definite shape. In liquids, the particles are close to each other, but they can move around. Liquids have definite volume but no definite shape. They take the shape of the container in which they are placed. However, in gases, the particles are far apart as compared to those present in solid or liquid states, and their movement is easy and fast. Gases have neither definite volume nor definite shape. Comparisons between the characteristic properties of these states of matter are given in the table. Look at them carefully and notice the properties. These states of matter are interconvertible by changing the conditions of temperature and pressure. On heating, a solid usually changes to a liquid, and the liquid on further heating changes to the gaseous or vapor state. In the reverse process, a gas on cooling liquefies to the liquid, and the liquid on further cooling freezes to the solid. Classification of matter. On the basis of chemical composition, matter can be classified as mixtures or pure substances. Mixtures are further classified as homogeneous mixtures and heterogeneous mixtures. Similarly, pure substances are further divided into 2 categories, elements and compounds. Let us discuss these substances one by one. A mixture is a physical combination of two or more substances where the substances retain their original identity. A homogeneous mixture is a solution that has a uniform composition throughout. For example, the salt cannot be identified in a salt solution after dissolving and mixing it thoroughly. On the other hand, a heterogeneous mixture does not have a uniform composition. For example, a mixture of sand and iron fillings. Now, let us discuss the pure substances and their types. Unlike mixtures, pure substances have fixed composition. An element is the simplest form of matter that cannot be split into simpler substances or built from simpler substances by any ordinary chemical or physical method. These consist of only one type of particles, which may be atoms or molecules. Oxygen and hydrogen are the examples of elements. A compound is a pure substance made up of two or more elements combined in a definite proportion by mass, which could be split by suitable chemical methods. Water and carbon dioxide are the examples of compounds. Properties of matter. Every substance has a unique or characteristic property. These properties can be classified into two categories: physical properties and chemical properties. Physical properties are those properties which can be measured or observed without changing the identity or the composition of the substance. Example: color, odor, melting point, boiling point, density, etc. Chemical properties are the properties that require a chemical change to occur. These include acidity or basicity, combustibility, etc. Many properties of matter, such as length, area, volume, etc., are quantitative in nature. Any quantitative observation or measurement is represented by a number followed by units in which it is measured. For example, length of a room can be represented as 6 meters. Here, 6 is the number and m denotes meter, the unit in which the length is measured. The International System of Units, abbreviated as SI, is a common standard system established for measuring the different quantitative observations. The SI system has 7 base units, which pertain to the 7 fundamental scientific quantities. The SI system allows the use of prefixes to indicate the multiples or submultiples of a unit. To indicate very small numbers, we use negative exponents. To indicate large numbers, we use positive exponents. Properties of matter and their measurements. Mass, volume and temperature are the 3 fundamental properties for measuring different objects. Mass and weight are the measure of the amount of matter in the object. Mass of a substance is the amount of matter present in it, while weight is the force exerted by gravity on an object. The SI unit of mass is kilogram. Volume is the amount of space enclosed by a shape or an object. Volume has the units of length cube. So volume has units of meter cube or centimeter cube. The common unit liter is also used for measuring the volume of liquids. 1 liter is equal to 1000 milliliters and 1000 centimeter cube is equal to 1 decimeter cube. Next is density. Density of a substance is its amount of mass per unit volume. So, the SI unit of density is SI unit of mass over SI unit of volume, which gives kilogram over meter cube. There are 3 common scales to measure temperature: degree Celsius, degree Fahrenheit and Kelvin. Here Kelvin is the SI unit. The relations between Kelvin and degree Celsius and degree Fahrenheit and degree Celsius are shown. Uncertainty in measurement. The measurements of quantities in chemistry are spread over a wide range. Hence, a convenient system of expressing the numbers in scientific notation is used. In scientific notation, any number can be represented in the form n into 10 raised to the power n, where n is an exponent having positive or negative values and n can vary between 1 to 10. For example, we can write 232.508 as 2.32508 times 10 raised to the power 2 in scientific notation. Similarly, 0.00016 can be written as 1.6 times 10 raised to the power minus 4. Precision and accuracy are often referred to while we talk about the measurement. Precision indicates how closely repeated measurements match each other. However, accuracy indicates how closely a measurement matches the correct or expected value. A result is valid only if it is both accurate and precise. The uncertainty in measurements is taken care of by specifying the number of significant figures in which the observations are reported. Significant figures are meaningful digits which are known with certainty. There are certain rules for determining the number of significant figures. All non-zero digits are significant. Zeros preceding the first non-zero digit are not significant. Zeros between two non-zero digits are significant. Zeros at the end or right of the number are significant provided they are on the right side of the decimal point. But if otherwise, the zeros are not significant. During addition and subtraction, the result cannot have more digits to the right of the decimal point than either of the original numbers. Look at the example. Here, 38.0 has only one digit after the decimal point, and the result should be reported only up to one digit after the decimal point, which is 49.1. In multiplication and division with significant figures, the answer cannot have more significant figures than either of the original numbers. Take a look at the example. Since 2.5 has two significant figures, the result should not have more than two significant figures. Thus, it is 3.1. The dimensional analysis helps to express the measured quantities in different systems of units. Hence, it is possible to interconvert the result from one system of units to another. For example, 15 centimeters length of scale is to be converted in SI unit. We know 100 centimeters is equal to 1 meter. Then 15 centimeters is equal to 0.15 meters. Laws of chemical combinations. There are 5 basic laws of chemical combinations that govern every reaction. Law of conservation of mass, law of definite proportions, law of multiple proportions, Gay-Lussac's law of gaseous volumes, Avogadro law. Antoine Lavoisier established the law of conservation of mass. It states that matter can neither be created nor destroyed. Joseph Proust showed that a given compound always contains exactly the same proportion of elements by weight. This is called the law of definite proportions. Dalton proposed the law of multiple proportions. According to this law, if two elements can combine to form more than one compound, the mass of one element that combines with the fixed mass of the other element is in the ratio of small whole numbers. Gay-Lussac proposed a law according to which, when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all the gases are at same temperature and pressure. Avogadro proposed that equal volumes of gases at the same temperature and pressure should contain equal number of molecules. All these laws led to Dalton's atomic theory. Dalton's atomic theory. In 1808, Dalton published a new system of chemical philosophy in which he proposed the following. Matter consists of indivisible atoms. All the atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. Compounds are formed when atoms of different elements combine in a fixed ratio. Chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Atomic and molecular masses. We already know that the smallest particle of an element, which may or may not have independent existence, is called an atom, while the smallest particle of a substance which is capable of independent existence is called a molecule. For example, sulfur salt and sulfur atoms, water molecules. The mass of these atoms and molecules are expressed in terms of atomic masses and molecular masses, respectively. Atomic mass of an element is defined as the average relative mass of an atom of an element as compared to the mass of an atom of carbon-12 taken as 12. One atomic mass unit is defined as a mass exactly equal to 1/12 the mass of one carbon-12 atom, and 1 AMU atomic mass unit is equal to 1.66056 times 10 raised to the power minus 24 grams. Nowadays, unified mass U is used in place of AMU atomic mass unit. The atomic mass of an element expressed in grams is the gram atomic mass or gram atom. For example, the atomic mass of oxygen is 16 AMU. Therefore, gram atomic mass of oxygen is 16 grams. Molecular mass of a substance is defined as the average relative mass of its molecule as compared to the mass of an atom of C12 taken as 12. For example, the molecular mass of CO2 is 44 AMU. It is obtained by adding the atomic masses of all the atoms present in one molecule. Molecular mass of a substance expressed in grams is called gram molecular mass. For example, the molecular mass of oxygen is 32 AMU. Therefore, gram molecular mass of oxygen is 32 grams. Some substances such as sodium chloride do not contain discrete molecules as their constituent units. In such cases, the formula such as NaCl is used to calculate the formula mass instead of molecular mass. Formula mass is the sum of atomic masses of the elements present in one formula unit of a compound. For example, the formula mass of sodium chloride is 58.5 unified mass. Mole concept and molar masses. Just as we denote 1 dozen for 12 substances, 1 century for 100 substances, and 1 gross for 144 substances, we use the idea of mole to count entities at the microscopic level, that is atoms, molecules, particles, electrons, ions, etc. In SI system, mole was introduced as 7th base quantity for the amount of a substance. Mole is defined as the amount of a substance which contains the same number of chemical units, atoms, molecules, ions or electrons, as there are atoms in exactly 12 grams of pure carbon-12. A mole represents a collection of 6.022 times 10 raised to the power 23 Avogadro's number chemical units. The mass of 1 mole of a substance in grams is called its molar mass. For example, molar mass of water is 18.02 grams and molar mass of sodium chloride is 58.5 grams. The volume occupied by 1 mole of any substance is called its molar volume. It is denoted by Vm. 1 mole of all gaseous substances at 273 Kelvin and 1 atmosphere pressure occupies a volume equal to 22.4 liters or 22,400 milliliters. The unit of molar volume is liter per mole or milliliter per mole. Percentage composition. The mass percentage of each constituent element present in any compound is called its percentage composition. An empirical formula represents the simplest whole number ratio of various atoms present in a compound. For example, CH is the empirical formula of benzene. The molecular formula shows the exact number of different types of atoms present in a molecule of a compound. C6H6 is the molecular formula of benzene. The two formulas are related as molecular formula is equal to N multiplied by the empirical formula, where N is a simple number and may have values 1, 2, 3 and so on. By following the steps, one can easily determine the empirical formula of the given compound. Step 1. Conversion of mass percent of various elements into grams. Step 2. Convert mass obtained in step 1 into number of moles. Step 3. Divide the mole value obtained in step 2 by the smallest mole value out of the mole value of various elements calculated. Step 4. In case the ratios are not whole numbers, then they may be converted into whole numbers by multiplying by the suitable coefficient. Step 5. Write empirical formula by mentioning the numbers after writing the symbols of respective elements. Stoichiometry and stoichiometry calculations. Stoichiometry gives a quantitative relation between reactant and product in a reaction. It also helps us in identifying limiting reagents. What is a limiting reagent? The reactant which gets consumed first or limits the amount of product formed is known as a limiting reagent. For example, 10 molecules of hydrogen and 7 molecules of oxygen react and produce 10 molecules of water. It is found that 2 molecules of oxygen were retained after the reaction, whereas all the molecules of hydrogen were consumed in the reaction. Thus, hydrogen is a limiting reagent in the given reaction. Reactions in solutions. The concentration of a solution can be expressed in 4 ways. These are mass percent, mole fraction, molarity and molality. Let us discuss these one by one. Mass percent is the mass of the solute in grams per 100 grams of the solution. Mole fraction. It is the ratio of the number of moles of a particular component to the total number of moles of the solution. Molarity is the number of moles of the solute in 1 liter of solution. Unit of molarity is moles per liter. Molality is the number of moles of solute present in 1 kilogram of solvent.